Hello everyone, welcome you all. In the today's video, we are going to see HashSet collection in Java. So from the previous videos, we have understood collection is a root interface and the collection interface is extended into multiple child interfaces. So list is one child interface and set is another child interface and queue is another child interface. So these are three main interfaces which have derived from the collection root interface. Now list interface again implemented by using array list, which we have seen in earlier, and also linked list. So these are the two classes which I have implemented list interface. So today we are going to see about set interface. So what is set interface, when we need to choose set interface, and what are the different classes are available which I have implemented this set interface. So basically set is a child interface of collection, and set interface is again implemented by using two main classes. One is HashSet, the other one is linked HashSet. So these are the two main classes which have implemented set interface. So set interface is a child interface of the collection. So now we will discuss more about set interface, when we have to choose set interface, and HashSet class. This is the main class we are going to discuss today, and this is the child class which is derived from the set interface. So all whatever methods we have in the set interface which is implemented by the HashSet class. So now let us main focus on HashSet class. So what is basically HashSet means? So when we have to choose HashSet, normally if you want to represent like group of elements or group of objects as a single entity where the duplicates are not allowed, okay, duplicates should not allow, and insertion order not preserved. So in these two cases we go for a HashSet concept. So in the HashSet concept, in the HashSet class, here we cannot store the elements, like duplicate elements we cannot store, and insertion order is also not preserved. So what does that mean is, in whichever order we have inserted objects or elements into the HashSet, it will not be there in the same order. So it will be arrange all the elements or objects in the random order. So in the HashSet, duplicates elements are not allowed and insertion order is also not preserved. So these are the main two characteristics of the HashSet. Now we will discuss a few important points about HashSet. The first point is, as we discussed, duplicates not allowed, and the second point is insertion order not preserved. And this particular HashSet will insert the elements by using a concept called hash code. So hash code is a concept by which the elements will be inserted in the HashSet. So that's the reason searching of elements will be very faster in HashSet. Suppose we have a more number of elements. If you want to search a particular element, it will be very faster because internally it uses hash code concept while inserting the elements. So since it is not maintaining any order, so there is no index concept in the HashSet. So basically it is an unordered list. That means all the elements will be arranged in the random order. So there will not be a sequential order. So there is no index concept here. So hash code concept will be internally used while inserting the elements in the HashSet. Now heterogeneous data will be supported. So as we know, all the collections will support heterogeneous data. That means we can store different type of objects, different type of data elements in the HashSet. And along with this heterogeneous data, nulls also support. We can also add nulls in the HashSet. Okay, so these are the main important points which we have to remember while discussing about HashSet. So duplicates not allowed, insertion order is not preserved, and hash code concept will be used at the time of inserting the elements, and allowed the heterogeneous data, and nulls also allowed. Now, so when we need to go for HashSet, if you have search operations, like in your operations, the more number of operations are searching, then go for HashSet because searching will be very faster here. Now, so this is a child class of set interface. Now, let us see how we can create HashSet objects. How many ways we can create a HashSet object? How it is going to store or locate elements? So HashSet object can be created in many ways. So the first way I'll show you now, something called HashSet. So this is a way, HashSet, and create some object reference variable hs equal to new hash set. Okay, so this is a default way we can create a hash set object. So when I create a hash set object like this, so we are calling default constructor here, empty constructor. So by default it will allocate 16 locations. So the number of locations, so these are default size or initial size. We can say initial size. Instead of saying default size, we can say initial size. So initial size means it will by default allow us to store 16 objects or 16 elements. So this is a by default or initial size of hash set. But how we can store, how many elements we can store is along with this location. This is the initial value, like 16 locations will be there and 16 elements we can store. And apart from this size or location, there will be one more thing called load factor in hash set. Load factor, or we can also call it as a fill ratio. So this is a one more important thing in the hash set. So we need to understand two things here while creating the hash set object. One is defaultly, by default it is allocated 16, that is the initial size of hash set, and we can increase the size also later. And one more thing is load factor and fill ratio. So what is the load factor or fill ratio of hash set is 0.75. So 0.75. So this is representing 1%. This is called as a load factor or fill ratio. Now let us understand what is this load factor and fill ratio. This is most important in hash set. So before understanding what is this load factor and fill ratio, let me just give one example from the array list. And then we will come back and understand what is load factor. In case of array list, normally what happens is when I create array list, observe this array list ar equal to, right, new, I'll say array list. So I created one array list object like this. So when I create an array list object like this, by default how many locations will be created? 10 locations will be created. So here default size is 10. So 10 locations will be created. So if I add more number of elements, like say 10 elements I have added or 10 objects I have added in the array list, 10 locations are filled. Then I have added one more element called 11th object or 11th element in the array list. Then what happens is normally it will not directly add a value at the end of the list like this. So internally what happens is it will create another bigger array, and default size is 10 locations will be created, and all the elements in the previous array will be copied into the new object, and the 10th element will be added here. And this variable now refers to the new object, and the old object will be eligible for garbage collection. So every time when you're inserting or when you're removing the element from the array list, this object will be created, new object will be created. And most of the times whenever these locations are completed or filled with all the elements, it is reached maximum size, then automatically it will create a new object and the new elements will be added into the new object. So this is exact thing will happen in case of array list. So when this new object will be created, as soon as all elements are completed here, the locations are filled, then the new object will be created. So this will happen whenever you do additions and removing the elements in case of array list. The same thing is happening for hash set also. So in case of hash set, for example, let me just take HashSet concept. In the hash set, what happens is when I create a hash set object, by default 16 locations will be allocated. So I can store 16 elements. So I already added more number of 16 objects like this. So now the default factor, load factor is 0.75. So this is representing the percentage. Now what is the load factor means? Suppose 16 is the initial size of the hash set. So I added all the 16 elements. Now I want to add another element, 17th element. In case of array list, once it is reached 16, then it is created a new object. But in case of hash set, as soon as these locations have reached 75%, immediately it will go and create another object with the new size. So it will create 16 locations plus with the new object location. And then this object is referring to the new object and the old object is eligible for garbage collection. So in case of hash set, as soon as it is reaches 0.75, means 75% of the locations, immediately it will go and create a new object. So this is called as a load factor. load factor. So this is most important topic, load factor, or we can say fill ratio. So the initial size of hash set is 16 and load factor is 0.75. So when I create a hash map, empty hash map, by default 16 is the location, load factor is a 0.75. As soon as 75% of locations are filled, then the new object will be created. All the elements will move to or copied into the new object, and the new element also will be added. So this will happen whenever you add a new object into the hash set. So this is concept of load factor. Now, so can we control this load factor? So can you define my initial value? Suppose I want to store 100 elements or 100 objects. Can we define this, or can we control on this, or can we configure these two values? So to configure these two values, we can do that. So how we can do the configuration of initial value and the load factor of hash set? And to do this, we have to use another way of object creation. So for example, let us say here I'll say hash set hs equal to here new hash set, and here we have to specify. So default size is 16. Now I want to store 100 elements, so I can say 100. So here 100 is a initial size. And what is the load factor? Load factor are not mentioned here. So load factor still 0.75. So this is a load factor. But still, if I want to specify the load factor also, then I can say hash set hs equal to, I'll say new hash set of locations comma load factor. So load factor is always in the decimal format. Okay, so we can specify initial size and load factor, then automatically. So 75 is the default load factor. I can specify 90 or 95, something like this. So now as soon as as soon as the locations have reached 95%, immediately it will go and create another locations, and all the elements will be moved to the next object. So this is a main concept of load factor and initial location in the hash set. Okay, so we already seen like hash set will accept heterogeneous data. Suppose if you want to restrict that to specific type of data or specific type of object, we can still restrict. So for that I can say hash set, and here in the Angular brackets we have to specify what type of data you want to store. Suppose I want to store only numbers, so I'll say integer class hs equal to, here I'll say new, and again hash set, and in the Angular bracket we can specify the type of the class and close the bracket. So here and here we have to specify the type of object, what kind of objects we are going to store in the hash set. Okay, so these are the different ways we can create an object, and where we can configure the initial value, also we can configure the load factor. So load factor is very important in the hash set concept. Okay, so now we have understood what is hash set, and when you have to go for hash set, how the elements are going to store. So where the duplicate elements are not allowed, insertion order is also not preserved. So there is no index concept here. So now just like other collections, here also we can do certain operations on hash set by using different methods. Now let us see what are all methods are available inside the hash set, and different methods are available. And one more thing here we need to understand, like hash set is a class which is implemented set interface. Set is an interface, and hash set is a class which is implemented the set interface. So hash set is not having their own methods. There is no special methods in hash set itself. But whatever methods are there in the set interface, the same methods are implemented in the hash set. Other than those methods, hash set doesn't have any specific methods to this, which belongs to the hash set. Okay, so whatever methods are available in the set interface, the same methods are implemented in the hash set class. Now we'll see what are those methods available, and how we can use those methods to perform different operations on the hash set. So just like other collections, and here also we have certain methods. Suppose I want to add some group of elements into hash set, then we have a method called add. So here directly we have to specify the value. So here we don't have an index concept. So directly specify the value or object that will be added to the hash set. Add method is available. And also we have add all method. And here we have to specify some collection of elements, and group of elements will be added to the hash set. Add all is there. And we also have a remove method, which will, and in case of remove method, here we cannot use the index because here we don't have index concept. So directly we have to specify the object name or value which is there inside the HashSet collection, and accordingly that value will be removed. And similarly we can also remove multiple objects by using remove all. So here we can specify the collection and a group of objects will be removed from the HashSet. So add all, remove and remove all. Okay, so these are the common methods which have. Apart from this, and whenever use add method, we can just pass only value. So here we don't have any index concept, because in HashSet elements are arranged in the random order. So there is no sequential manner, it will not store. So all elements will be added or stored in the form of random. So randomly arranged. So here we cannot do any insertion and updation of the elements or objects. Okay, but in case of array list we can do that, but here we cannot do that because we don't refer any elements by using index. So these are the common methods we have. So apart from this, we also have a contains method. So here when I specify any object or element, which will check the element is present inside the collection or not. If the element is present, it will return true. If it is not present, it will return false. And similarly we also have contains all method, and here if you specify group of elements, it will check all the group of elements are present inside the HashSet or not, will be written. And apart from this, if you want to check a particular collection or HashSet is empty or not, we can have isEmpty method which is available. So this particular method will check. If it is empty, it will return true. If it is not empty, it will return false. IsEmpty method is also available. And along with this, we can also read all the elements by using for loop. For each loop is also there, and by using iterator method also we can read all the objects, all the elements from the HashSet collection. Okay, so these are all different things we have in the HashSet. And one more important thing is, in case of list or array list, we have done searching, sorting and shuffling and all. Here by using contains and contains all method, we can do searching operations, but sorting is not directly possible here. Sorting and shuffling is not directly possible. If all elements are arranged in the sequential order, then sorting and shuffling is possible. But here we don't have an index concept. The elements are arranged in the random order, so we cannot directly sort it. If you still want to sort it, we have to convert this entire HashSet into hash map or array list, and then we can do sort method by in the collections class. As we have seen in previous videos, in the collection class we have a sort method, and we can pass, first we have to convert this entire HashSet into array list, and that array list we have to pass it here in the collection.sort method, and then it will able to sort and it will able to shuffle. But we cannot directly sort and shuffle the objects or elements in the HashSet. Okay, so these are all different methods are available in the HashSet. And when we need to prefer HashSet, if you want to maintain elements in the random order where the duplicates are not allowed, then we can go for HashSet concept. Okay, now we'll see practically how we can use all the methods. Okay, right, so now let's move on to the demo part. Okay, now we'll see how we can work with the HashSet methods. So here I already created Java collections project which contains collection demo package. Now inside this I'm just creating a new class. I'll name it as HashSet demo 1. Let's take main method and then say finish. So first of all, let's see how many ways we can create an object of HashSet. The first way is commonly we do like HashSet, and here S is a uppercase letter, HashSet, and let's create one variable called hs equal to new HashSet. So this is a way we can create. Now we can import HashSet from java.util. This is a variable which we have created for a HashSet class, and this is a default HashSet object, and the default capacity is the default capacity. So the default capacity is 16, and what is the load factor here? The default load factor will be 0.75. Okay, now similarly if I want to create, this is our default capacity 16 and load factor is 0.75. Now suppose I want to configure this load factor and the default capacity, then what I can do is I can define like this: HashSet hs equal to new HashSet, and here I can specify 100. So 100 is representing capacity. So initial capacity, you can say initial capacity is 100, so which we can configure it. And suppose along with the initial capacity I just want to configure load factor also, then I can specify like this. I say hash set hs equal to new hash set, and here along with the locations. So for example, I want to just store 100 elements, let's say 100 and comma, and we need to specify the load factor. Suppose I want to specify 90%, I'll say 0.90, and this we have to typecast with a float. Okay, so this is the syntax which you have to use. And here the initial capacity is 100 and load factor is 0.90, so 90%. And this is one more way we can create hash set object. Suppose I want to restrict the type of objects, like so I want to store similar kind of objects in my hash set, then I can create like this. I'll say hash set hs is my reference variable equal to new hash set, and here we have to specify the type of the elements, like what kind of object it is we have to specify. Suppose I want to store only numbers, I'll say integer wrapper class here, and also here I can specify like this. Okay, so these are the different ways we can create hash set objects. Now once we created hash set objects, now we'll see how we can add elements, how we can remove the elements, how we can read the elements or object from the hash set. Now let me just use the first syntax, which is more popular and very familiar, and let me just comment the rest of them. Okay, now let me just take the first one. So this is my default capacity is 16 and load factor is 75. Okay, now so once we created hash set object, we can access all the methods which are present inside the hash set. So how we can add elements into hash set? Now we'll see that. Add objects or elements into hash set. Okay, how to add objects or element into hash set? So simply we can use add method, sh dot add of, so it will by default accept heterogeneous data, so I can pass different type of data. So I'll say 100. Similarly, I can also add more number of elements. So here I'm just adding some other value, let's say welcome, and here I will add a decimal number, let's say some decimal number, and here I will add some character, and here I will add some boolean value which is true, and then here I'll add js dot add, I can add null also, I can add, so nulls also accepted. Okay, but duplicates not allowed. Okay, so this is a way we can add all the objects into hash set. So once we added all the elements, now I want to print them. I can say system dot out dot println, I can specify the hash set object, so that will print all the elements. Now this is a very important point. So in which order we have inserted all the elements, so this is the exact order we followed, but hash set will not maintain any order, so insertion order is not preserved. Now when I print this object, let us see in which order these elements will be printed. So when I run as a Java application, now observe, so in which order it is printed. So first null is printed, then a 100 16.4 welcome, and then true. So these are the values or objects aligned in random order. So insertion order is not preserved. So sometimes after some time, if you run the same code again, this order will be different. So that means insertion order will not be preserved. So that's the first important point. Next one. So here insertion order not preserved. Not preserved. Okay, and now we'll try to remove object or element from the hash set. So how to remove it? So to remove it, we have a method available called hs hash set object dot remove. So here we don't have an index concept, so what we can do is we can just directly specify the value. So I want to just remove 16.4, so that I can directly specify like this, 16.4 will be removed. So after removing this, so here the 16.4 is a value, not an index, so it will not accept any index here. So after removing the value, let us try to print this again. So I'll say system dot out dot println, I can simply say sh after removing the element, after removing element or object. So I'm just again printing the hash set elements. Now let us execute. So now we got these elements. So this time 16.4 is removed and rest of the elements are printed in the random order. So here we can use a remove method along with the value or object we can specify. Now suppose I want to get a specific value from this HashSet. Directly we cannot get. So here we don't have a get method. Okay. So if you want to read all the data, we have to write a loop statement and then we can read each and every object from this HashSet. Now similarly we cannot also modify the existing value here. Okay. So we don't have set method to update the existing value. So here after removing we can verify whether that object is element is present in this HashSet or not. So for that we have another method called contains. So this method will check the object or element is present in this HashSet or not. So for example, let's say hs dot contains method I can use. I'll say hs dot contains, and here contains, and directly we specify the value. So suppose I want to check welcome is a value or object which is present or not. I can pass this. So this will return either true or false. If this element or object is present in the HashSet, which will return true, or else it will return false. Now I'm printing that value. I'll say system.out.println hs.contains and welcome. So this is how we can check whether this value is present in the HashSet or not. Similarly, if I want to get some other value, let's say xyz I'm giving. So this is not there in the HashSet, so that should return false. So when I run this, the first one returned false because this element is not present. So why it is not present? Because here I say w and here it is a lowercase letter. So that's the reason the first one also returned the false. So it is a case sensitive. So now I have changed this. When I run this, the first one is returns true because that element or object is present inside the HashSet. The second one is returned false so that it is not present. So contains method we can use like this. And suppose I want to check this HashSet is empty or not. So simply I can say hs dot is empty. hs dot is empty. So this will return true if it is empty, and if it is return false if it is not empty. So currently our HashSet is not empty, so it will return false. I'll say system.out.println hs dot is empty. So this should return false. Now let us run this code. So which will return false. So basically it will check our HashSet is empty or not. Okay, so now we'll see how we can read all the objects or element from this HashSet. So to read all these objects or element from the HashSet, we can use either for each loop or we can use iterator method. So these are the only two ways we have to use to read the data or elements or objects from the HashSet. So the first method I'm using reading objects or elements from HashSet using for each loop. Okay, for each loop. Now how we can do that? I'll say for, and here I'll specify the hash map object element. Let's say HashSet hs, and I'm going to read each and every data element into one variable. So here I'll create one variable called object type variable, so that this variable will be able to hold all kinds of data. And from this object or variable, I'm getting the value. So I can directly print this. I can simply say system.out.println and specify the value. So this variable. So every round of iteration from the hs, it will get you one element in this object variable. Then it is printed here. So let us run this code. So when I run as a Java application, so which will print all the data from the HashSet. Again, it is in random order. You will not expect in the same order because it will not maintain the insertion order. So this is the first way we can get all the objects or elements from the HashSet. So apart from this, we can also use iterator method to get the data. So for that, we have to create one iterator class object. Let's say iterator, let's say id equal to new id equal to hs is my HashSet object. So dot iterator method we have to access iterator. So when I call this method from the hs, it will get all elements into it. So iterator we have to import from java.util. Now from this it we have to extract each and every value. So for that I can say while loop, and here I will just specify if it dot has a next element, and then I will print that element. I can say system dot out dot println, and here I can say, okay, system dot out dot println. Here I'll say it dot next. So this method will verify, it will just print the existing element on this, and then it will move on to the next element. So this loop will repeat multiple times till it printed all the objects or element from this hash set. Now let us execute now. Right click, run as Java application. Now here we got the same data. So this is how we can also use iterator to read all the data element from the hash set. Now let me show you a few more things on the hash set. Let me just go back and let me discuss few more methods. Let's create another class. I'll say HashSet demo2. HashSet demo2. So here, let me just show you a few more methods. Let's say we have add all and remove all methods. Add all and remove all methods. So how we can use those methods in the hash set? So let me just create one hash set like this. I'll say hash set and HS, or we can simply say some variable name I'm creating. Okay, so I'll say even number equal to new hash set. Okay, new hash set. So in this even number hash set is this object of hash set, and I want to store only numbers in this, only integer numbers. Then I can explicitly specify the type of the object, integer here and also here, integer. So now hash set should be imported from java.util. So now I created one variable which can hold data elements. Now I want to add few elements in the even number. So here I want to add few elements. How to add even number object dot add, and here I can specify some numbers. I'm going to add few numbers into this object. I'll say 2 is an even number, 4 is another even number, 6 is another even number. So I'm just added 3 elements into this hash set. Now I'm going to print them. I can say system dot out dot println even number. So this is my object reference variable. So this is my even number. Okay, so here I got, so I'm just saying hash set. I'm just printing that message and then followed by numbers. So when I run this, which will give you all the elements, so 2 4 6. So now it is given in inserting order, but every time don't expect it should be followed in the insertion order. So 2 4 6 is given, so this is printed 2 4 6. So now I have just created one hash map variable and I have added 3 elements into hash map. Now even number contains a 3 different elements. Even number contains a 3 different elements. Now I'm creating one more hash set, one more hash set, and this name of the asset is numbers equal to new hash set. And this is also, in this also I'm going to store only numbers. I'll say integer, and here also I'll specify the integer. This is one more hash set. So we already created one hash set with even number which contains the 3 data elements. Now I am created one more hash set called numbers. So inside this hash set also I'm just going to add few more elements. So what are the elements I'm going to add in this is whatever elements we already added into the even number hash set, the same elements I'm going to add into the new hash set. Okay, so how we can add? So just I want to add this even number hash set object into this one. So by using add all method. So now you can use like this, numbers dot, you are adding multiple data elements. So we have to use add all, and here we have to specify the collection. So what collection we have already created? Hash set is a one collection we created which contains a multiple elements. So we can specify directly here. Now what this method will do is this will add whatever data elements we have in this hash set, even number hash set. The same number of elements will be added into the new hash set. And apart from this, I will also add one more element into this, like I'll say numbers dot add, and here I'll add 10. Now observe, So numbers is a new hash set which we have created, and I am adding all even number hash set. So whatever elements we have in the even number hash set will be added to the numbers. Along with that, I'm also added one additional element which is 10. Now let us print all the elements which are available in the numbers. So for that, I can say system.out.println. Here I will say new hash set plus I'm printing the numbers hash set here. Okay, so along with this collection, I'm also added one more element. So what is our expected output here is 246 along with the 10. So these are the elements we get it from here. So this is how we can use add all method. So all this I'm just showing you to demonstrate add all method. Okay, and similarly we also have one more method called remove all method. So how we can use this remove all method? So from this number, so currently what are the values we have in these numbers has a hash set? We have 4 values, 2, 4, 6 and 10. So I want to remove group of elements, that is 2, 4, 6. Okay, and 10 should be there. 2, 4, 6 I want to just remove. So how we can remove them? Numbers dot I'll say remove all. So when I say remove all, group of elements or collection we have to specify. So 2, 4, 6 is present inside the even number collection. So that I am going to specify here. And now what the statement will do is this will remove all method will remove the data element from the even number. Whatever the data elements we have in the even number, the same data elements will be removed from numbers. Okay, now I'm going to print the rest of the elements. System.out.println. I'll just print numbers. Okay, this is a hash set. Numbers I'm printing. So here previously hash set contains the 4 elements, 2, 4, 6, 10. Now I removed all even number elements, and then it will remove all the even number elements, and whatever the rest of elements we have in the numbers, that will be printed here. So remove all method we can use to remove group of elements. So now we can see only 10 is left and rest of the elements are removed. So this is how we can use add all and remove all methods. So apart from this, we can also do some more actions on the sets. Normally in the mathematics we do. So whenever a set, we can do union of 2 sets. I have a 2 sets are defined. I want to do union, or I want to find a common elements between 2 sets like intersection, or I want to find the difference between 2 sets. So how we can do that? So we have a certain few more methods are available in the hash set to perform a union, intersection and differences. Now let us see how we can use those methods. So here I'm just creating one more class, and he'll say hash set demo3. Let's take a main method and then finish. So here let me just demonstrate how we can perform union of sets, how we can perform intersection of set, how we can perform the difference, like how we can find the difference between 2 sets. So union, intersection and difference. So we don't have union all, because if I say union all, duplicates element will be there. So hash set will not allow you duplicate elements. So we have only union, intersection and difference. Now we'll see how we can perform these operations by using different methods from the hash set. So before that, let me create one hash set which contains a number of elements. So I'll say hash set and set equal to new hash set. And here I want to store only numbers in this hash set, so I can just explicitly specify integer type, and the same thing I will specify here. Now import this hash set from java.util. Now I want to add some elements into the set, so let me just name it as a set1, because if you have a 2 sets, then I can perform these operations. Now set1, I'll say set1 dot add, so I'm just adding a new element, let's say 1. Similarly, let me add a few more numbers. 1, this is 2, this is 3, 4 and 5. So 5 elements I have added, 1 to 5 numbers I have added into the hash set. Now let me just print the set1, system.out.println, and I'm just printing the set1 as set1, and the elements are present inside the set1. Okay, now I have created one hash set. The name of the hash set is set1, which contains 5 elements. Now similarly, I will also create one more set, then I can perform union, intersection and difference. So I will create one more hash set, and this I'll call it as a set2. I'll say new hash set, and this is also having same kind of data, which is integer. So I'll just say integer class here and here. So this will allow us to store only numbers. So in the set2, I'm adding one more element. Let's add 3, and similarly I will also add few more numbers. I'll say 3, 4 and 5. So these are the 3 elements which we have inside the set2. So now again I'm trying to print set2 also here, and has set2 and now execute. So now I have just created 2 sets, set1 and set2. Set1 contains these elements. These are the elements we have in the set1, and these are the elements we have in the set2. Okay, so now let us see how we can perform the union. So what is union means? It will collect all the elements from the set1 and set2, and it preserve only unique elements. It will remove all the duplicates. Okay, so it will find out a unique elements from the set1 and set2. So for that, what you can do is we have to use a method called add all. Observe this. So from the set1 dot add all. Okay, add all of set2. Now what this method will do is, whatever the elements we have in the set2, all those elements will be added to the set1. If there are any duplicates, it will remove those duplicates and it will preserve only unique elements. Now when I print set1 here, this will give you union results. I'll say system.out.println, and here I will say union, and I'll print set1, and this will give you elements which are matching with the union. So 1 2 3 4 5. So these are the elements we have in the set1. So 1 2 3 4 5, this is a result of union for both the set1 and the set2. And similarly we can also do intersection. Intersection means the common elements between two sets. In set1 and set2, whatever the common elements we have, we can get it. So that is called intersection. The common elements we can get from the set1 and set2. So for that we have to use one more method. Let me comment these two. Now for that I can use set1 dot. We have a method called retain all. I'll say set1 dot retain all. So this is the method. So here I'll say set2. Here I'll say set2. So what exactly this method will do? Retain all means except these set2 elements, rest of the elements will be retained. Except this set2. So that will give you the common elements, intersection part of set1 and set2. So what are the common elements we have in the set1 and set2? Only 3 4 5 are the common elements which we have in the both. So by using retain all method we can get it. So after that, let us try to print set1. System.out.println, and here I'll print intersection elements. So here I can say set1. Okay, now this will give you the common elements between two sets. Now you can see 3 4 5 are the common elements between two sets. So by using retain all method we can get the common elements. And suppose I want to find the difference. So set1 and set2, what are the difference elements we have in the set1 and set2? That is basically called as a difference. Now how we can find the difference of set1 and set2? So simply here we can say from the set1 remove all of set2. So what this method will do is, from the set1 elements, from the 1 2 3 4 5, it will remove all set2 elements. In the set2 what are there? 3 4 5 are there. So 3 4 5 will be removed from the set1, and what are the rest of elements? 1 2 are there. So these 1 2 are the elements, they are the difference between set1 and set2. So here I will print the difference. I'll say system.out.println, and here I can say difference, and I'll print set1. Okay, and then I'll comment this. So this will give you the difference between set1 and set2. right? So now we got 1 comma 2. So this is how we can get the difference between two sets, and we can also get the subset of the set. So how we can get the subset? Okay, subset, how we can get the subset? So here I can say, let me comment these two statements, and here I can say set1 dot, there is a method called contains all. Set1 dot contains all, I'll say set2. What exactly this method will do is contains all will return either true or false. Okay, so contains all set2, so whatever the elements we have in the set2, they are 3 4 5. Okay, and those elements are available in the set1. Okay, if whatever elements we have in the set 2, so the same elements are available in the set 1, that will be written true. Okay, so now let us try to print this set 1 contains all, basically. So we can say system.out.println, which will give you the subset elements, basically. System.out.println, and here I can say subset of set 1. All right, so subset it will print. So what is a subset here means? So set 1 contains 1 2 3 4 5, set 2 contains a 3 4 5, and apart from these 3 4 5, if these 3 4 5 contains in the set 1 also. Okay, and what is the other elements we have, that will be returned, that is a subset of the set 1. So here contains all set 2 will verify in set 1, and other than those elements it will be written rest of the elements. So set 2 contains 3 4 5, set 1 is also contains 3 4 5, other than those three elements, what are other rest of elements we have will be written as a subset. So this command will return the subset of the element from the set 1. So that will contains all. So let me, okay, so 1 2 3 4 5. Okay, perfect. Let me just print it. Okay, I commented everything. So here set 1 contains all set 2. Now I have printed set 1. Perfect. Now let me save it and execute. So this is given subset 1 2 3 4 5. Okay, so basically this command contains all will return either true or false. Boolean value will be written. If the set 2 having three values 3 4 5, and set 1 is also having 3 4 5 along with 1 2 3, right? So these elements are already contained in the set 1. So this command will exactly returns true or false. So let us try to print here system.out.println, and set1 dot contains all of 2. So this will return either true or false. And if you want to print subset like this, we can say set1. So set1 is basically having 1 2 3 4 5, so it is printing like this. So let me just comment this and run this command. So contains all method will return the set2 elements are present in the set1, then it will return true. If that means if the set2 elements are part of the subset of set1, so if the set2 elements are subset of set1, then it will return true, or else it will return false. So when I run this as a Java application, now it is written true. So that means basically what it is verifying, the set2 is a subset of set1 or not, it is verifying. So whatever elements we have in the set2, they are also having in the set1. So the same elements are having in the set1 also, so it is returning true. So basically it is verifying whether the set2 is a subset of set1 or not. If it is a subset, then it will return true, or else it returns false. Okay, so we can just remove this statement. So this is how we can use, or we can do some kind of union, interaction or intersection and difference and subset operations on the HashSet. Okay, so this is how we can use all the methods on HashSet collection framework in Java. Okay, so that's all for this video guys, so thanks for watching.